everyone. In the last couple of videos, we learned how to solve polynomial and non-polynomial equations, where we were given an equation and our goal was to find the roots. Now let's consider the case when we are not given an equation and what's in hand is just a bunch of coordinates in xy form. And we are asked to establish a relationship between these variables. Or, in a more formal way, to find a relationship between dependent and independent variables. So the process of establishing a relationship between these kind of variables is called regression. There are many different types of regression depending on the type of relationship we want to establish. For instance, linear regression, if we want to create a linear relationship, and a quadratic relationship. In that case, it will be called quadratic regression, and so on. So in this video, we will learn a bit of theory of linear regression, and then in the later section, we will do some hand-on exercise in MATLAB. Therefore, it's important for you to watch the video till the end. So let's consider a case when we are given, say, 5 or 6 or say whatever number of points, and our goal is to come up with a line that relates all these points. So we know that the standard equation of a straight line is y is equal to mx plus c, where m is the slope or gradient of the line and c is the y-intercept, which is the point where the line intersects the y-axis. So we are not going into the detail of how to derive m and c in this case. So all we need to know is that there are some equations or established relationships that we need to know. And again, it is not important at all to remember these clumsy equations, but what is important is to learn how to compute these parameters. Let's head over to MATLAB now and try to implement the concepts that we have learned so far to find out the line that can map the points that we have shown earlier. So here I have written a MATLAB code, and I'll walk you through this code line by line. So in the first section, I have cleared the environment by clear, close, and CLC commands. And then I define the points, all those 5 points that are shown in the previous slide. And n is here the number of elements. Just to show how the plots, how the points look like, I have written this plot command. And then if you see in the previous slide, the first step was to calculate the means of x and y coordinates. And x bar is the variance of x coordinates. And for the covariance, we have to do this formula as shown in the previous slide. So that gives us xy covariance. And then we can compute our desirable parameters m and c, or you can say alpha, beta, or ab, or whatever you can say. So this shows that we have our, in this case, m comes out to be 10 and y-intercept comes out to be 42.2. So to test this whole thing, we can plot this thing with the test data. So we define x test and y test, and we plot the same. So now we can see in our plot both the points and the line that relates the whole point. Of course, it's you can see it's not really fitting into all the points, but that somehow goes into the middle of these points. That indicates that this is a better representation of given coordinates. Well, in the real life, when we have to do somehow exact fitting, we use more complex models of regression. And regression is one of the most widely used techniques in machine learning to fit the data. But we have to be careful that we should not overfit and underfit the data. This is something that we cover in advanced topics and not the scope of this video. I hope I'll cover this topic in somewhere in future. So that's it for today, and thank you for watching.